All right, good morning, everyone. What I'm going to be talking about today is blockchain and circular supply chain. And this is a topic that is going to take us from a basic sort of economics view of how blockchain technologies work. And I want to map that into circular supply chain, circular economy, economics. But before we do that, I want to sort of try and discuss first how economists actually view blockchain technology. So the broad context of this is what I want to call first and second wave automation. So first wave automation is basically labor capital substitution of machines for people. This was the beginning of the Industrial Revolution, where we had machines coming in to replace animals and human labor and other forms of essentially human beings in the economy, automated with machines, drove the Industrial Revolution, and a whole lot of the just essentially long-run economic growth and development that has happened over the past few hundred years has been driven by automation technologies. I'm going to call that first wave automation because of its labor capital substitution in the sense of human beings being replaced by software or machines or robotics or other sorts of things. The final wave of this is basically autonomous robots. We think of these as sort of self-driving cars or factory robots or other types of advanced automotive technology, absolute state-of-the-art sort of things. But what's key to distinguish this is that this type of automation is automation where it is replacing human output and power and labor within that. Blockchain technology isn't an extension of that type of industrial automation, but is rather the beginning of a new type of automation, which I want to call second wave automation. And second wave automation is basically machine technologies, software in this case, but it can start to go beyond that, where machines are basically making decisions in order to govern human activity. So it's not so much labor capital substitution in an industrial economy. What we're dealing with here is a new type of automation, which is institutional or governance automation, where software technologies, machine technologies are providing an automation layer around economic governance. That's what's new with blockchain technology. So what blockchain technology is for an economist is that what we're dealing with here is this new type of automation, this new type of labor capital substitution, but labor capital substitution focused on governance, that is fundamentally about economic infrastructure. And economic infrastructure refers to the layers of institutions that govern economic and human to human, human to machine, economic coordination of technologies that facilitate economic activity. So what we mean by blockchain technology is autonomous digital technologies, basically software, that provides base layer economic infrastructure for a digital economy. So what we mean by blockchain then is this fundamentally new set of technologies that are driving economic institutions and innovation into the economic infrastructure layer of an economy. And that's what is fundamentally different about this type of technological innovation compared to industrial innovation, or first wave automation, as I described it before, which was essentially driving technological innovation into the industrial parts of an economy, substituting capital for substituting labor for capital and driving economic productivity through that. What blockchain technology, as the first sort of wave of second generation automation, is driving governance technologies or new forms of governance technologies into an economy. What we mean by distributed ledger technology, blockchains, is that ledgers are an institutional technology for consensus about social facts. Social facts being information about identity, about contracting, about ownership, about a whole series of facts that we need agreement and consensus about in order for economic activity to take place. I need to know who my counterparty is. I need to know facts about ownership in order for transactions to occur. These are social facts what blockchains are doing is recording consensus or agreement about these social facts that makes it an institutional technology. So distributed ledgers, an open source software technology that facilitates a new type of economic infrastructure. All right, why is that important? Industrial technologies such as robotics and machines and tractors and actuators and hydraulic rams and other types of fundamental aspects of industrial automation produced labor capital substitution that were just simply more powerful than the human or animal equivalents of that, right? So that's where you got these productivity enhancements from, just more powerful use of being able to move things around the world and so on. The economics of blockchains as an institutional technology is not that it enables us to do physical things better, faster, cheaper, but it enables us to provide automation of governance in an economy. And that automation of trust, that economizing on trust is what blockchain technology automation enables us to do. So it enables us to move into an economy where promises work better, where agreements can be made, where information entered into a system, any one part of the system is replicated in other parts in a trustless way, enabling agreements to simply work better, enabling information to move further and with less need for costly verification. That's the basic economics of what blockchains do, is that they economize on trust, enabling promises to work better, and that's it. What that means is that that trades off against a world of competition with market-based economic institutions or governance, which is hierarchic-based economic institutions such as firms or governments. So blockchains are a new institutional technology that has a lower cost of trust, or it economizes on trust, enabling us to use blockchain institutions, blockchain-based economic institutions as economic infrastructure, rather than relying on market-based institutions, which use competition as their mechanism for driving them, or governance-based institutions, or hierarchic governance-based institutions in particular, both of which can simply be expensive. So the economics of blockchains is they just lower a key cost in an economy, the cost of trust, enabling us to use less and more expensive trust mechanisms, including markets and hierarchical organizations instead. So that sort of high-level overview is the point I want to make about why economists are excited about the institutional prospects of blockchain technology. So what do we mean by this? So the problem, well, the notion of the cost of trust is related to the idea of that there is simply an economy, any economy where you've got groups of people coming together to coordinate, to trade, to produce things, to jointly create value, means that I need that all of the components, or all of the sort of economic agents in a system need to be able to trust their counterparties or have information that they can reliably use about their counterparties, about who they are, their reputations, the assets they claim to own, and the properties of those assets and goods and other goods and services, in order to facilitate coordination and exchange and production. So that base layer institutional condition of just knowing and agreeing about social facts, creating consensus about social facts, is what ledger technologies do. Now, there's different ways of doing this. A peer-to-peer ledger, also peer-to-peer trust, as you might find in a small village or just a group of a hunting party that knows each other well, can create high-quality, low-cost trust just simply through repeated interactions, and you get to know the other people that you're seeing every day. That situation produces low-cost trust, but it doesn't scale very well. So the problem with this type of trust that's created peer-to-peer is that it works very well in a small local situation. It works very poorly when you scale that up to the level of a nation state, or just when you push it over the horizon. Another technology of trust in honor of Thomas Hobbes, we call Leviathan, is the idea that we have an overarching party that will provide trust to all of the citizens or denizens or subjects within the realm. So a king, a powerful leader, an all-powerful god of some sort, but just this idea of an overlap of an overarching, and Hobbes called it the Leviathan, that will provide trust to all of the subjects within it. That notion of trust works when human society has lived for long periods of time under such institutional governance regimes, but it is costly in the sense that you have to give a huge amount of power to that agent that is providing that. The more modern industrial form of manufacturing trust is through intermediaries. We jointly agree to trust a third party, and that mutual trust of a third party facilitates exchange and coordination. Now, that third party might be a company, such as a bank. We can facilitate payments between each other if we both trust and use the same counterparty, an intermediary. So modern economies more or less use a combination of these, actually all three of these things. Local trust, Leviathan in the sense of we trust government, and intermediary trust in the sense that we trust third parties in order to facilitate our trade, our exchanges, our economic activity. Blockchain technology is an additional architecture of trust in the sense that it has the benefits of peer-to-peer trust in the sense that it's mutual and fully network compatible. But unlike peer-to-peer trust, which works very well in small groups, blockchain trust as an architecture is designed to scale up to a very large peer-to-peer network where the counterparties aren't necessarily known to each other. So it has the benefits of peer-to-peer trust, but with the properties of an intermediary, with the overall facilitation created by the sort of Leviathan architecture. So blockchain technology is a new architecture of trust that we create. Now, why would we do that? The main sort of implication here is that trust is a necessary condition for any economic production and more economic activity, but it is expensive. So the cost of trust that we provide has to take into account what economic infrastructure needs to be created, or the economic costs need to be incurred to provide that infrastructure. So with peer-to-peer trust in a small group, relatively small costs in terms of monitoring, but the huge cost is an opportunity cost in terms of scale. With the Leviathan model, the cost is that you have to trust the king, or you have to trust the leader, and they have enormous amounts of power that can be abused with that. You also tend to see relatively low levels of innovation in that type of trust architectures. With the extensive use of intermediaries, the problem is that those intermediaries can capture a lot of the value of trust. Now, some work that myself and colleagues have done in the past few years just sought to put a back of the envelope calculation on what the size of trust or what the cost of trust actually is in a modern economy. And using US labor force statistics, we just went through and more or less estimated for each occupational class the extent to which that is the extent to which the main service being provided there is the manufacture of trust. Our back of the envelope calculation puts this about a third of the economy as trust. Is that significant? Phenomenally so. It makes it on the order of a sort of $30 trillion global industry, which means that about 1/3 of global GDP is devoted just purely to the manufacture of trust. Is that wasted? Well, no, because we need that as a crucial input in order to provide economically valuable resources such as trade and production. But that trust has to be produced in the first place in order to enable global economies and economies beyond just small villages to actually work. So we need some technology to manufacture trust, but we want to do that at as low a cost as possible. So the basic argument about why blockchain technology is economically important and significant and potentially revolutionary is it's a new architecture of trust that has a lot of the benefits of peer-to-peer network trust, but scales potentially to the size of a global economy. that can be done at orders of magnitude lower cost than the cost of the conventional ways of manufacturing trust, which, as we emphasize here, is on the order of about a third of the economy, give or take. So trust is a huge thing that needs to be produced in a modern economy. Blockchain is a new technology to lower the cost of trust. So from an economic perspective, what blockchain is doing is it industrializes the manufacture of trust by enabling us to automate the governance of this key economic institution. In the same way that electric motors and steel production and steam engines and petrol engines and other sorts of industrial technologies automated industrial production and therefore drove huge productivity into an economy that created wealth. What blockchain technologies are a new type of automation that dramatically lowers the cost of the manufacture of trust into an economy. What that does is it economizes on opportunism. If we can trust information, if we can trust shared data, if we can trust shared social facts about identity and ownership and contracting, that lowers the hazards of opportunism, which reduces the costs of needing to monitor and incur costs verifying and auditing and checking information and contracts and so on, which just means economies can run so much more efficiently. And that's the basic argument about why economists look at blockchain technology and see a fundamentally profound new type of general purpose technology that's not an industrial technology, which is the main sort of technological change that we're used to, but is an institutional technology that facilitates governance and coordination in an economy, and a dramatic lowering in the cost of trust, minimizes the hazards of opportunism, enables a potential explosion in the range and scale of economic activity that can take place. And that's the argument for the economics of blockchain. It's a new type of institutional technology that produces a far more efficient ability to contract, to trade, to exchange, to organize coordination and production. Now, a key place we find the use case for that is in supply chains. So this is the connection between blockchain as an institutional technology and the thing I want to talk about now, which is supply chain technology. So supply chain technology in the context of a circular economy. I want to just set the problem up and show the main point I want to make in this talk is the idea that what we're fundamentally dealing with here is an information problem. And blockchain technology helps us to resolve this in the same way that that market technology creates efficiencies in the modern economy. So, first point to note: a supply chain is an economy. A supply chain is the process of a good or a service starting at one point and moving through a series of steps to arrive somewhere else in the world, usually transformed, whether it's been added to or processed in some way, but value is added through a series of steps that take place. So a supply chain is an economy. A circular supply chain, we're trying to resolve this problem of creating a circular supply chain where all information is contained within it, is simply a circular economy. So that sort of helps us understand that what we're dealing with here is technologies to create a circular economy. Next part of the equation here is to recognize that an economy is by definition an information problem. One of the sort of ways of thinking of an economy is that it's an allocation problem, where you've got a set of resources and the task is to allocate those resources to their best possible use. The modern way of understanding the economic problem is not as a planning problem from outside the system, but rather as a mechanism design problem from within a system, where you're trying to make the most efficient and best use of all of the information that is available to the system, and therefore to design a mechanism that maximizes information efficiency and information use in such a way that you're capturing that you're lowering the cost of processing and using information and maximizing the efficiency of the use of information. Now, another way of saying that is that an economy is fundamentally a computational problem. And that's the modern view of how to understand the economic problem, is the design of efficient mechanisms or programs, if you will, that make best use of all of the information available and effectively compute value. So that modern view of an economy as computation and of the economic problem as an information problem implies that the circular economy challenge, this how do we design and create the most efficient circular economy we can, so that all resources are maximally used and as little as possible leaks outside, is equivalent to defining the economic problem as a information completeness problem, or as a computation problem where we make use of all of the information that is available. So with that in mind, the major sort of progress in 20th century economics was around the understanding of the market as a mechanism to compute information, and the idea of a market as a distributed mechanism that made use of distributed information. That's the modern mechanism design understanding of why markets are more efficient mechanisms than firms, or markets are more efficient mechanisms than planning, or any sort of hierarchical mechanism, because they make better, more efficient use of distributed information. That's associated with the work of economists such as Mises or Hayek or then Hurwitz. But that notion of market mechanisms or market efficiency is the key way of understanding this notion of how do we design effective economies. So the one thing we want to add into this story then is that what blockchains bring into this is a contribution to moving us toward complete information, or to lowering the cost of ensuring that all information is able to be computed by the economic mechanism that we're going to design. So that notion then of a circular economy or a circular supply chain defined as an information problem leads us to the idea that what the role of blockchain in this is in facilitating the completion and adaptation that is made possible by an economic mechanism as an information processing mechanism. So that's the direction we want to go. So I wanted to distinguish that from the standard use cases in which blockchain supply chains are discussed. It's the three main use cases at the moment are provenance, which is perceived as a consumer challenge, where we want blockchain supply chains to be able to add information about the origin of a good or service, where did it come from, what's in it, and so on, and to have that information preserved as the good moves along the supply chain, such that the final consumer or the various stages along it, manufacturers can establish at low cost information pertaining to provenance. Where did this thing come from? How do we know it is what it claims to be? So that's sort of information completeness. The other name for provenance is just high trust, low cost information completeness that starts at the beginning of the process. So that's the center one. The other sort of use case is around essentially cryptocurrencies and tokenization to facilitate payments technologies that move up and down a supply chain. So enabling enabling trade finance, for instance, or various payments to be made using digital currencies along supply chains. The other sort of significant use case is just hard coding regulation into supply chains to lower the cost of compliance, and that was a lot of trade costs are associated with meeting regulatory rules at different stages of a supply chain. This might be labor laws, this might be sort of food quality laws, or laws associated with just any aspect of meeting the trade or customs or security or just or sort of biosecurity laws along that. And again, that goes to this problem of sort of intermediation, that there are costs of verifying and auditing information that occur to third parties along the way. By automating that ability to verify and check information as it has gone, as it is entered onto a supply chain, we can lower the costs of dealing with compliance. So provenance, which is information verification, looking down a supply chain, payments and trade and trade finance, which is dealing with just the ability to use blockchain technologies to add layers of payments rails over the top of the supply chain, and regulatory compliance, which just simply means hard coding regulatory rules into a blockchain supply chain, are all use cases that lower the costs of supply chain as economic infrastructure. But the argument that I want to make is an additional argument to that, which is this notion that what we mean by a circular supply chain or a circular economy in the context of trade is simply the use of this technology to ensure information completeness, to enable us to have information that is added at the beginning of a supply chain about the origin of a good and anything that is added to it or any services that are performed to it, and to be able to track all of that information, ensure all of that information is complete along a full production process, enables us to move toward complete information sets. Now, that's analogous to complete markets or to have sort of zero cost property rights in a system of complete markets, which gives us this sort of this notion of perfectly efficient prices. Now, that's a series of assumptions about transactions costs need to be made in order to ensure that that happens. But the analog between a circular supply chain is and as a theoretical concept is the same as the idea of complete markets and informationally efficient prices associated with total information. So this notion of creating circular supply chains in a circular economy context is the analog of complete markets and the efficient prices that generates. So what we mean by a circular economy is to sort of first conceptualize a hypothetical instance of an economy in which every transaction, every production process for every good can be fully and completely specified. That's a world of zero transactions costs. It's a world of a perfect description of all things in an economy. Now, in such a world, provided we can track every transaction, everything that happens to everything within that, we can map out a hypothetical perfect economy in which we can track every good within that and all of the things that happen to all of those goods within that. That's a definition of a circular economy in the sense that everything within that will therefore be priced, and every commodity, every sort of thing that exists within an economy will be priced all the way through from beginning to end. That notion of completeness in a perfect market also assumes this idea of a perfect ledger, that we have a complete record of everything that is occurring within it. So any conception of a circular economy, of a perfectly circular economy, needs to approximate not just this idea of market completeness, but also ledger completeness. What does a perfect ledger look like? In a perfect ledger, we have zero information loss. We also have a perfect set of a complete list of all of the goods in an economy. We have perfect property rights in an economy, and all of the trade and transactions, the exchange of property rights within an economy occur with zero loss of information throughout the system. Now, that's something that has never been possible before because all industrial economies essentially work through intermediation. You've got different parties trading with different other parties and so on. And information does not move throughout the entire process. It is only replicated across each individual step. So the idea of having a perfect ledger that keeps track of every transaction, every additional bit of information that is added to a good or service as it moves through, with zero loss of information, is the hypothetical, and they emphasize hypothetical, that would enable us to create a circular economy within that system. So what we have in an actual economy is something where we have information loss, or entropy with trade. So if we assume we start off with a perfect description of the starting points of an economy in terms of primary goods being produced, with each transaction or with each production process, we lose information within that because of the cost of information. Onto that, by the time we get to the end of a production process, there's very little information left, just simply because it is lost throughout the process. That is the main argument for why circular economies are hard to do. It's information loss as we move through. So the basic promise of blockchain technology is just simply to reduce the loss of information, or to reduce the entropic effect of transactions and economic complexity on information as it moves through an economy. And if we can do that, we approximate, or we get closer to this idea of a perfectly circular economy where there is no information loss about things about all the trade and transactions within it, which also then translates into the idea that consumers and everyone in an economy can make full use of all of the information within it. We get complete markets, perfectly efficient pricing within that, and therefore rational activity in an economy. So the conclusion I want to point to here, as a sort of high-level point of this talk, is that the way in which we get towards a circular economy, the way in which we get to as close as we possibly can to minimizing the amount of waste in an economic system, is a problem to be defined as an information problem of minimizing the loss of information through a series of trade and transactions. It's a problem of entropy and information loss through the design of mechanisms that minimize information loss and maximize information continuity through an economic process, through a process of trade and transactions. Now, I raise that because that is not the way in which modern circular economies are approached. They're largely approached as a regulatory problem, where the goal is to provide a series of regulations that raise the cost of anything moving outside of a pricing mechanism or slipping outside of an economy, i.e. becoming, circular effectively means staying inside an economy. That all of the externalities and processes and products associated with economic transactions stay within an economy. So the idea of, what is the basic contribution of blockchain technology to the creation of a maximally efficient, waste minimizing circular economy, is that what blockchains do is they dramatically lower the cost of keeping information inside the economy. And that notion of extensive use of blockchains into supply chains, of finding more and more ways to push blockchains into supply chains, therefore becomes a fundamental way in which we can seek to design better economic institutional infrastructure for circular economies by lowering the cost of keeping information inside them. And that fundamental argument there is exactly the same argument around market completeness. To maximize economic growth and human welfare, we want to move toward complete markets. To maximize the prospect of arriving at a circular economy with the environmental benefits that brings, that minimizes the risk of environmental hazards, we need to push blockchains into as many supply chains as we possibly can, because that maximizes the probability that we're going to have information contained, effectively circular, to ensure that all information stays within an economic system, to minimize information entropy and maximize price efficiency within an economy. Another way of describing that is we have the efficient markets hypothesis, which more or less says that if we have perfect information and costless and zero transactions costs, prices are highly efficient, prices are efficient information in an economy. The same argument applies to what we might call the efficient ledger hypothesis. If we can lower the costs of blockchains as economic infrastructure, we move towards complete ledgers. If we move towards complete ledgers, we move toward complete information that can stay within an economy, and that takes us toward a circular economy. So the broad sort of argument I want to make in conclusion is that advancing blockchain technologies deeply into supply chains moves us towards a circular economy. Thank you.